Hi everyone, once again welcome back to our class. Now we are going to discuss about the numerical problems and concepts based on the kinematic equations of motions. Some applications. Okay, the body projected upward direction with initial velocity u. Then the kinematic equations of motions changes from one equation to another form, and the time of flight, time of ascent, time of descent, and some etc. concepts. Okay, here first of all, this topic is only for used for JEE mains and NEET. Okay, just applications of the kinematic equations of motions. Okay, listen, first of all, your first problem here, applications of the kinematic equations problem. Here a body dropped freely from a multi-stored building can reach the ground t1 seconds. It is dropped in its path after t2 seconds. It is dropped its path after t2 seconds. Okay, stopped. Okay, t2 seconds is stopped, and again dropped freely from the point. Find the further time taken it to reach the ground. Okay, find out the time after further time taken to reach the ground. First of all, the multi-story building, the height of the multi-story building, for example h1, for example capital h1. Okay, the body is dropped from the multi-story building. This body to reach the ground, here time taken t1. Okay, next here, second case here, it is stopped in its path after t2 seconds. The body is stopped at multi-story building at midpoint or below midpoint or above midpoint. t2 seconds here stopped. After the body dropped freely, the body touches the ground after time. Find out the time here. Find the further time taken it to reach the ground. Okay, now first of all, a multi-floor building, height of the multi-floor building here, for example multi-store building. This is a, for example, ground. This one here just for ground. Okay, the height of the multi-story building, this is the, for example, height of the multi-story building. Okay, this is a h1, for example here h1. This is a body, this body dropped from the some height, h1 height. This body to reach the ground, here time taken here t1, time taken here t1 time. Okay, time taken here to reach the ground t1 seconds. Next, it is stopped in its path after t2 seconds. Okay, this dropped body at any point its path, for example a point, the body is stopped. Okay, at a point, the time taken to reach the point a, here t2, for example here time t2. The displacement of the particle from upper store to here point a. So for example O is a initial point, so the body dropped from O point to reach the point a point. The time taken here just to t2. Here displacement of the particle, this body here, for example this one h1, this is the height here h2. The body stopped some time at a point after the body dropped. This body here dropped. Okay, this body here dropped. Here initial velocity also here 0. The time taken to reach the ground here, for example t2 question mark, here t2 question mark. The displacement of the particle in this case here a point to a point b nothing but here point on the ground, bc here, for example here height h3. Okay, OB h1, OA h2, AB here h3. The time taken to reach the B point, here time taken first point t1, time taken second case here time taken O2, B here t2, Third case here, after dropped here A to B, a time taken here just to T3, question mark here T3, here displacement of the particle its path here A to B here H3. So the height of the multi-stored building here H1 is equal to here H1 is equal to here H2 plus H3, H2 plus here H3. This is a H1 means height of the multi-stored building. Here H2 means AO, H3 means AB. Now using the S is equal to U2 plus half at square formula, the second kinematic equation of S is equal to U2 plus half at square. So the body is dropped. That means here the body moving from rest. Okay, moving from rest. Here H1 is equal to, first case here S is equal to UT plus half at square. This is a second kinematic equation. Now first case here time taken T1, here displacement is path here H1, S is equal to U is equal to here 0, U is equal to here 0, here also here 0, here also 0. Okay, now first case here, this is a H1 is equal to U into T plus 1 by 2, here A is equal to G, here A is equal to the body moving downward direction, downward. So A is equal to, this is a taken as here positive, now of G T1 square, so H1 is equal to of G1 G T1 square, this is the equation, for example 1, this is the equation 1. Next, the body to reach the O to A point, here time taken here T2 seconds, so the displacement here H2, so here H2 is equal to 1 by 2 G2 square, according to this same formula application. Okay, applied this same formula. So H2 is equal to half G T2 square. Okay, this is equation, this one here equation 2. Okay, next further here the body to reach the ground, here time taken here T3, the body moving from A to B. So here initial velocity at A point here U is equal to 0. That means here the body stopped. Here the body it is stopped in its path after T2 seconds. So here also some time taken stopped. So the body dropped from the A point. So initial velocity at A point here 0. So in third case here H3 is equal to same T3 square. So this is a equation 3. We want here time taken to reach the ground from A to B, now H1, H2, H3, these three values here substituting above equation. So equation 1, equation 2, equation 3 substituting in this equation. So here H is equal to just half GT1 square, okay, from 1, 2 and 3, 1, 2 and 3. Okay, half G T1 square is equal to T1 square, H2 means this one, H2 of G2 square plus of your G3 square. Here of G is common term, of G common term. So simplifies, taken cancel terms, here T1 square is equal to T2 square plus T3 square. We want here just to T3, we want here time taken to reach the ground from the A to B point, that is equal to here T1 square minus, this is taken left side, T2 square is equal to just here T3 square. So therefore T3 square is equal to under root of here T1 square minus T2 square. This is the time taken to reach the ground from point A to B, okay, this is the answer. Okay, first of all H1 is equal to the H1 nothing but here height of the multi-stored building. Okay, H2 AB, H3 here H2 OA, H3 AB, H1 here O to OB. This is the equation. Next, the kinematic equations of motion for a body projected vertically upwards. The body projected vertically upwards. The velocity goes to upward direction. The velocity is decreases. The acceleration due to gravity taken as here negative. For example, the body some might drop, some might. Its velocity gradually increased. At the same time, the acceleration due to gravity is constant, but it is taken as here positive. Okay. Now, the kinematic equation of motion for a body projected vertically upwards. Okay. Note this one first of all. Now, the kinematic equations of motion for a body projected vertically upwards. Okay. Now here the initial velocity of the body, projected body here u, for example, at any point its path, the final velocity here v, the time taken, the point midpoint, for example any point here t here, for example kinematic equations of kinematic equations of motion for a body projected vertically upwards. Okay, upwards. Here, for example, this is a ground. For example, this one here ground. Okay, for a body projected upward direction with initial velocity u. Okay, this is a ground. For example, the body projected upward direction. The body projected in upward direction with the initial velocity here is the initial velocity u. Here, at any point its path. For example, this is a point at a point. For example, A is a point, its path. The body to reach the point A with velocity v, for example here v, not this body to reach the maximum height, but the body its path at any point, at any instant of the time. Okay, the body to reach the point A with velocity v. This is a final velocity, this one here initial velocity. Okay, the displacement of the particle in this condition here, for example yes. Okay, the body moving upward direction, the velocity is gradually decreasing. The acceleration due to gravity taken as here negative. That means here A is a constant, nothing but A is constant, nothing but acceleration is a constant. That acceleration is equal to acceleration due to gravity. Here this is taken as negative. Okay, here t is equal to just t. So the kinematic equations of motions, first equation kinematic equation, v is equal to u plus here at. Okay, here s is equal to displacement s, here a is equal to g, t is equal to t, here v is equal to v, u is equal to just u. Initial velocity, time, acceleration, displacement to here velocity, final velocity at point. Okay, here first kinematic equation, v is equal to u here plus a is equal to minus g. Okay, so v is equal to u plus into minus here minus gt. This is a first kinematic equation, the body projected vertically upward direction. Next case here, second one, here s is equal to ut plus of at square. Now here s is equal to s, same yes. Okay, u is equal to u, t plus here 1 by 2 into a is equal to just g t square. So plus into minus, displacement, this displacement is equal to ut plus into minus here minus of gt square of gt square. This is a second kinematic equation. Next, the body to reach the v point v with velocity v. So the relation between final velocity and initial velocity displacement. Okay, the relations here. Third kinematic equation, v square minus u square is equal to 2as here, that is equal to v square minus u square. Okay, u square is equal to here u square plus 2as. So v square is equal to u square plus here 2 into minus g into just s. A is equal to minus g. Simplies v is equal to u square plus into minus here minus 2g s. This is the relation between final velocity, initial velocity and displacement of the projected body. The fourth kinematic equations, Sn is equal to u plus a by 2 into 2n minus 1. Okay, here fourth kinematic equation here, Sn is equal to u plus here a by 2 into 2n minus 1. So here displacement is equal to Sn is equal to u plus here a is equal to minus g by 2 into 2n minus 1. So here plus into minus. So Sn is equal to u minus g by 2 into 2n minus 1. Okay, this is the fourth kinematic equation of motion. So okay, once again, for a body projected vertically upwards with velocity, initial velocity u, at any instant of the time, its path at any point, the final velocity here at a point, for example v. Okay, the displacement here s, acceleration is equal to g, t is equal to t. This is the upward direction. Here first kinematic equation, v is equal to u plus at, that is equal to v is equal to u minus gt. Second kinematic equation, s is equal to u2 plus half at square, that is equal to s is equal to u2 plus ut minus of gt square. Third kinematic equation, v square minus u square is equal to 2as. So v square is equal to u square minus 2gs. Fourth kinematic equation, s is equal to u plus a by 2 into 2n minus 1, that is equal to Sn is equal to u plus g minus g by 2 into 2n minus 1. This is the four kinematic equations of motion, the body project vertically upward direction. Now the equation parameters, the velocity parameters, the body project vertical upward direction. Now the time of ascent, the time of descent, the time of flight, and some etc. Okay, first of all note this one. Here these are very important. These are concepts, very most important here. Motion parameters of a body projected vertically upwards. Motion parameters of a body projected vertically upwards. Now maximum height equation, time of ascent, time of descent, and time of flight equations, some formulas. Okay, first of all, time maximum height for a body, for example, for a body projected vertically upwards. Okay, the body to reach the maximum displacement, position, the velocity of the body at maximum displacement position will be 0. So that point is called here the displacement is here maximum height. The here initial velocity u, final velocity of the body at maximum height will be 0. Okay, first of all, the time of maximum height. Next, time of flight. What is the time of flight? For a body projected vertically upward direction, the body to reach the maximum displacement position at the velocity will be 0 at that maximum displacement position. This is called here time of ascent. Once again, the maximum displacement of the body to reach the maximum height, along the vertical direction, this is called here time of ascent. The time of descent, for a body projected vertically, the time to reach the maximum to reach the ground from the maximum displacement, maximum height. This is a here time of ascent. ఇక్కడ ఏంటంటే సింప్లీ ఫస్ట్ ఆఫ్ ఆల్ ఈక్వేషన్ ఆఫ్ మోషన్లో మ్యాక్సిమం డిస్ప్లేస్మెంట్, ఓకే, మ్యాక్సిమం height, maximum height, this is a here, okay, h maximum for a body. Here for a body projected vertically, here vertically upwards, okay, verticals, the body, the maximum displacement the maximum displacement of a body from the maximum displacement of a body to reach the maximum displacement position at to reach the maximum height position. Once again, any concept for a body projected vertically upwards, the maximum displacement of a body okay, some just changes for a body at maximum height at here at maximum height simply for a body projected vertically upwards, okay, the maximum displacement of a could be small changes, the maximum displacement of the projectile body along vertical direction, okay, upwards, the maximum displacement along vertical direction, along vertical direction, along vertical upward direction, upwards direction is, this is a vertical direction, is known as here, is known as maximum height, okay, maximum height. It is denoted by here, it is denoted by h maximum, it is denoted by h maximum. For example, here simply this is a ground, for example this one here a ground, the body projected from the ground along vertical direction, with velocity, initial velocity u, its initial velocity u, at maximum height, maximum displacement position, its velocity will be 0. For example, here O is a maximum height point, maximum height displacement position, O is a maximum displacement position. At O point, the final velocity will be 0 at O point. That means here V is equal to just to 0. This is O is a maximum displacement position, okay. The maximum height here, for example, this is a O is a point of projection, okay. O is a point of projection, O is a maximum displacement position. The distance between here A to O, this is a indicates here, gives here the displacement of the projectile, body, projectile body. This is here maximum height. Okay, the acceleration, the body moving along the vertical direction, the velocity gradually decreasing. That now the acceleration due to gravity taken as here negative, so that is equal to here a is equal to minus g. Okay, here we want just equation of maximum height. So here formula here v square, third equation of motion, u square v square minus u square is equal to just 2as. Okay, 2as. So s is equal to maximum height, displacement of the position. Here a is equal to minus g, and here v is equal to final velocity of the projectile body at point O. V is equal to 0. Here initial velocity u is equal to just initial velocity u is equal to just u. These values here substituting. Now simplifies here v square, that means here 0 square minus u square is equal to minus so 2 into minus g. A is equal to minus g, the h is equal to maximum height. So simplifies u square is equal to plus into minus 2g maximum displacement, or that is equal to maximum height. So minus get cancel, simplifies here u square is equal to 2g h maximum. That means here therefore h maximum is equal to u square by 2g. This is the maximum height of the projected body. Now next, time of ascent. The time of ascent means here the body projected vertically, for a body projected vertically upwards. Okay, the time taken for the body to reach the maximum height, is called as a time of ascent. Okay, note this one first of all. Here displacement, ఈ డిస్ప్లేస్మెంట్ ఇంకా ఎన్ని రకాలుగానే చెప్పుకోవచ్చు, డిఫరెంట్ మెథడ్లో స్టేట్మెంట్స్ ఉంటాయి. ఓకే, ఫర్ ఏ బాడీ ప్రొజెక్టెడ్ వర్టికల్ అప్వర్డ్స్, ద మ్యాక్సిమం డిస్ప్లేస్మెంట్ ఎలాంగ్ వర్టికల్ డైరెక్షన్. దిస్ ఇస్ అ వర్టికల్ మీన్స్ హియర్ అప్వర్డ్స్. ఓకే, వర్టికల్ డైరెక్షన్ ఈజ్ నోన్ యాజ్ హియర్ మ్యాక్సిమం height. It is denoted by h. So v square minus u square is equal to 2as. Formula here s is equal to h maximum, a is equal to minus g, v is equal to 0, u is equal to u, that is equal to finally h maximum is equal to u square by 2g. Now time of ascent. The body, for a body projected vertically upwards, the time taken to reach the maximum height, the time taken for the projected body to reach the maximum height is called as here time of ascent. Okay, here time of ascent, it is denoted by here just ta. Okay, once again, the time taken for the projected body to reach the maximum height, is called as a time of ascent. Okay, once statement, the time taken for a body to reach the maximum height, to reach the maximum height from the ground. Okay, that means from the point of projection. That means here from the point of projection. Point of here projection. Point of projection is known as time of ascent. Okay, time of ascent, it is a okay ta. It is a ta. Now just here, this one here ground, this one here just ground. Okay, the body projected vertical upwards with the initial velocity u. This is the body projected vertical upward direction with the initial velocity just u. The body to reach the maximum height, that means here o is a maximum position, displacement position. Okay, The final velocity of the body at O point here, this is equal to here 0. The time taken to reach the point O here, that is equal to time of ascent. Time of ascent, that means here t is equal to just ta. The t is equal to just ta. Okay, we want time of ascent according to the first equation of motion. V is equal to u plus at. Okay, now here a is equal to just a, s is equal to maximum at u is equal to u, v is equal to u 0, and a is equal to here, a is equal to body the moving vertical direction, so a is equal to minus g. Now from equation here, from equation, the first kinematic equation, from equation here v is equal to u plus here at, u plus at. So here a is equal to minus g, t is equal to just here t is equal to ta, v is equal to g, here u is equal to just u. Okay, now these values here substituting, simplifies here. V means 0, v means here 0, and u here initial velocity plus a into minus a mean nothing but here g, here t is equal to ta, time of ascent. That means here 0 is equal to u plus into minus t gta, so gta, so this taken here left side, that is equal to minus u is equal to minus gta, minus can cancel, u is equal to gta here, ta is equal to time of ascent is equal to u by g. This is the time of ascent formula, this one here time of ascent. Time of ascent ta is equal to u by g. Next, the time of descent. Now the time of descent is called defined as, for example, the time taken for the projected body to reach the point of projection from maximum height. Okay, this is called as here point of time of descent. That means, once again, the time taken for the projected body to reach the point of projection from maximum height, this is called as a time of ascent. అంటే వస్తువుని నిట్టనిలువ వదిలేసినట్టయితే, విసిరినట్టయితే దాని యొక్క ఉన్నత స్థానం నుండి నేలను చేరడానికి పట్టిన కాలాన్ని ఇక్కడ అవరోహణ కాలం అంటాం. దీనికి ఇక్కడ ఏమంటారు? అవరోహణ కాలం అంటాం. ఓకే, నౌ నో దిస్ వన్. ఫస్ట్ ఆఫ్ ఆల్, time of descent. Here time of descent, that means time of descent okay, time of descent, that means here td. Okay, td. Here the time taken for the projected body, the time taken by the projected body, to reach the ground, to reach the ground, that means to reach the point of projection, to reach the point of projection, from the maximum height, okay. Maximum height is known as here time of ascent, time of descent, here time of descent, this is a td. Okay, td, it means here this is a, for example, ground. This is a ground. The body projected vertical upwards, with initial velocity u. Its initial velocity here 0. Here O is a, for example, O is a point of projection, upward direction. with initial velocity u, with initial velocity u, this is the initial velocity u at point of projection. This body to reach the maximum height O, for example O, here for example A is a maximum displacement position. At maximum height, the final velocity of the projected body, here v is equal to 0, v is equal to 0. The displacement of the body to reach the maximum height, here s is equal to just here h maximum, h here maximum. Okay, further the body to reach the point of projection, finally the body to reach the point of projection, the time taken for the body to reach the point of projection from maximum height, is called as a time of descent, so here now first step here, step 1, okay, step 1, okay, step 1, first of all here point of projection u is equal to here v square minus u square is equal to 2as, here a is equal to minus g, a is equal to minus g, upward direction, here u is equal to just u, okay, the v is equal to 0 at a point, here displacement s is equal to h maximum, h here maximum, okay, these are substituting in this third kinematic equation, so that means here v that is equal to 0 minus u square is equal to 2 into here a is equal to just to g minus g, here s is equal to h maximum, that means here u square 0 0, so remaining u square is equal to plus into minus 2g h maximum, that means minus get cancel, get cancel, simplies here u square is equal to 2g h maximum, so the maximum height h is equal to here u square by 2g, this is the equation 1, this one here equation 1. First of all, the body projected vertically upward with the initial velocity u, the final velocity of the body at maximum displacement position a, v is equal to 0, the displacement of the projectile body along vertical direction s is equal to h maximum, a is equal to minus g, now further the body to reach the point of projection, again come to back its point of projection, okay, this is a initial, your final velocity here v maximum, for example v maximum, now we find out the final displacement here, the initial velocity here, equal to 0 at a point, the body to reach the starting point here a point, that means dropped point, a is a drop point, u initial velocity u, the displacement along vertical downward direction, s is equal to h maximum, the time taken to reach the ground, that means ground nothing but point of projection, so here a is equal to just g downward direction, here t is equal to td, the point of projection, this is a time of descent, okay, t is equal to td, a is equal to just to g, here s is equal to maximum height, this one downward direction, step 2 here, okay, step 2, this one step 1, this one here step 2, okay, now here s is equal to ut plus of at square, this is a second kinematic equation, this one here second kinematic equation of motion, here a is equal to downward direction, so g, here t is equal to td nothing but here called time of descent, next displacement s is equal to h maximum, these values here substituting, now h maximum is equal to s is equal to h maximum is equal to, here u is equal to 0, here initial velocity u is equal to 0, okay, u is equal to 0 into t plus here of A means here G, A is equal to just to G, here T is equal to TD, T is equal to here TD square, so simplies H maximum is equal to 0 plus 0 something multiplication something that is equal to 0 plus 1 by 2 G TD square. So H maximum is equal to, simplies here, H maximum is equal to of G TD square. This is the equation 2. This one here equation 2. Okay, this is equation 2. Now from equation 192, here X maximum is equal to U square by 2G. Here equation compared to the equation 192. Okay, note this one. First of all, once again statement here, time of descent statement, the time taken by the projected body to reach the point of projection from the maximum height is called as here, is known as here time of descent. It is denoted by TD. Okay, it is denoted by TD. Now here equations 192, from equations 192, here equation 1, H maximum is equal to this one, U square by 2G, and equation 2 here, H maximum is equal to 1 by 2 TD square. So the H maximum values here, U square by 2G. This one, this is the substituting here, simplies U square by 2G is equal to 1 by 2 GT square, GTD square. Okay, here 2 get cancel, 2 here get cancel, remaining simplies U square is equal to G into GT square, G square TD square. So here TD square is equal to U square by here G square, U square by G square. Okay, this is the taken denominator. So U square by G square, that is equal to TD square. So TD square is equal to time of descent square is equal to U square by G square. Simplies TD square is equal to here U by G whole square. So square get cancel, simplies time of descent is equal to U by G. This is a time of descent, the formula of time of descent. అంటే నీలం చేరడానికి పట్టిన కాలం ఎంత అంటే here TD is equal to U by G. That means here time of ascent is equal to here time of descent. Time of ascent is equal to U by G, and also the time of descent to TD is equal to U by G. So therefore the time of ascent, okay, note this one. First of all, note this one, the time of ascent is equal to the time of descent. Note this one, the time of ascent here TA is equal to U by G, and here TD is equal to U by G. That means here therefore time of ascent is equal to here time of descent. Okay, time of descent. That means here U by TA is equal to TD, that is equal to U by G. This is a time of ascent. Next, the time of flight. That means the body projected vertical upward direction. The sum of the time of ascent and time of descent is called as a time of flight. The body projected vertically upward direction. So the time taken to reach the total time taken to reach the point of projection. That means the sum of the time of ascent and the time of descent is called as here time of flight. Okay. Now time of flight statement, the sum of time of flight here, time of flight, this is denoted by capital T, this is denoted by here capital. Okay, the sum of time of flight, 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 the sum of time of fli ascent, the time of ascent and the time of ascent and time of descent, okay, time of descent is known as is called here time of flight, okay, time of flight. Here the time of ascent means TA, the time of descent means here TD, that is equal TA is equal to U by G and TD is equal to U by G, that is equal to here time of flight denoted by capital T is equal to TA plus here TD. So T is equal to U by G plus U by G, that is equal to here T is equal to 2U by G. This is the time of flight formula, this one here time of flight formula, okay. Note this one. Next, some applications. Here, see here two important, these are a very important complicated and simply used for JEE mains and NEET, okay. Your first case applications, just maximate applications, velocity at half of maximum height v is equal to u by root 2. Show that at maximum height, the velocity of the projectile body at maximum height v is equal to u by root 2. Your second one, the velocity at 3/4 of maximum height, 3/4 of maximum height v is equal to here v is equal to u by g, here v is equal to just u by root 2. Show that these two formulas, how to we will get this formulas, how to solve to that formulas and that equations. First of all, the body here, some note this one 2 points. For example, the body project vertical upward direction, okay. The velocity at any point during its journey is equal to the velocity at the same point during the downward journey. That means here the body projected vertically upward direction, okay. For example, its journey, this is a straight line is a path of the projectile body, okay. At point, for example, its path here, for example, this is a point here, O is a one point, okay. What point? The upward direction. First of all, upward direction, the velocity of the body at O point is equal to this one. That means here the velocity of the projectile along the vertical direction at any point during journey is equal to the velocity at the same point during journey downwards. అంటే ఒక వస్తువుని నిట్టనిలుగా వదిలినట్టయితే ఏ బిందు దగ్గర అయినా సరే వెలాసిటీ పై దిశలో పోయినప్పుడు ఎంత వేగం ఉంటుందో కింది దిశలో వచ్చినప్పుడు అదే బిందు దగ్గర అదే అంతే వేగాన్ని కలిగి ఉంటుంది, ఓకే. దిస్ ఇస్ నోట్ దిస్ వన్ పాయింట్. నెక్స్ట్ పాయింట్, the velocity of the projection. For example, here O is a point of, this is a P point is a point of projection. Here P point is a point of projection. The velocity of the point of projection is equal to the velocity, striking velocity. That means here upward direction, for example U, here downward direction, same point here, for example V. That means here U is equal to V is this one, V maximum nothing but here that is equal to striking velocity, downwards striking the body to touches the point of projection. This is a striking velocity, okay, at point of projection. Here the point of projection, velocity of the point of projection at point P is equal to U. That means here projection velocity is equal to striking velocity. అంటే ఒక వస్తువుని నిట్టనిలుగా వదిలినప్పుడు ఆ వదిలే బిందువు నుంచి మనకి ఎంత వేగం ఉంటుందో మళ్ళీ అదే బిందువుని చేరినప్పుడు ఫస్ట్ ఎంత వేగం ఉంటుందో మళ్ళీ అంతే వేగంతో అదే బిందువుని చేరుతుంది. ఇది దీస్ 2 పాయింట్స్ వెరీ ఇంపార్టెంట్, ఓకే. నౌ ఫస్ట్ ఆఫ్ ఆల్ show that the here velocity of half of maximum height v is equal to u by root 2. Show that the maximum height v is equal to u by root 2. Second case here, velocity at 3/4 of maximum height v is equal to u by 2, okay. Show the first case here. First case, this is a ground, this one here ground, this height is here maximum height, this is a maximum height. Okay, P is point of projection, here P is here point of projection, just to point of projection. Here Y is maximum height point, Y is a point, maximum height point. Here H means maximum height, H means here maximum height. Here given problem here, velocity at half of, here half of maximum height V is equal to, ante at point, for example here this is this point is a here PQ, Q point is a midpoint of the maximum height, midpoint of the maximum height. That means here Q means half of the maximum height. Ante here S is equal to just H by 2, S is equal to here H by 2. S is a displacement, the displacement is equal to half of the maximum height. Okay, the body projected vertically upward direction. So here initial velocity U is equal to just U, the acceleration A is equal to minus G. Okay, acceleration A is equal to here minus G. Okay, now the velocity of the projectile at O point, at Q point here, at Q point here just to V, question mark here Q, here V is equal to just to U by root 2, U is equal, V is equal to root 2, U by root 2, we show that formula. Now first of all that case here S is equal to H by 2, S is equal to H by 2, okay, comma A is equal to minus G, A is equal to minus, U is equal to here U is equal to just U, and V is equal to question mark here, V is equal to question mark here, that means here V is equal to U by root 2, we show that the velocity of the projectile at half of the maximum height V is equal to U by root 2. So here first of all maximum height formula U square by 2G, maximum height formula here U square by 2G. So here formula V square, third kinematic equation of motion, V square minus U square is equal to 2AS. So S means H by 2, okay, V means just V square U square, here 2 into here A is equal to minus G, A is equal to here minus G, S is equal to H by 2, S is equal to here H by 2. So simplifies V square minus U square is equal to plus into minus 2G into H square by 2, H by 2, just H by 2. So 2 get cancel, 2 to here get cancel. Okay, simplifies V square minus U square is equal to minus 2GH. So here H is equal to maximum height, the maximum height is equal to U square by 2G. So here simplifies V square minus U square is equal to minus 2G U square by just 2G. Okay, U square by 2G. So 2 get cancelled remaining, so 2 here get cancelled, sorry. V square minus U square is equal to minus GH, minus here GH. So V square minus U square is equal to minus G into U square by G. Here GG get cancelled, get cancelled. Simplifies one step, V square minus U square is equal to just U square minus U square by 2, So this is taken right side, U square is taken as here right side, the negative values here just positive. That means simplifies V square is equal to U square minus U square minus U square by 2, this one LCM, so 2U square minus U square by just 2, okay, 2U square minus U square remaining here U square. So this is a V square. Simply V square is equal to U square by 2, So finally the velocity of the projectile body at half of the maximum height V is equal to, here V is equal to simply under root of U square by G. That means here V is equal to U by root 2, this is the answer. Okay, the velocity of the projectile body at half of the maximum height V is equal to U by initial velocity by root 2, root 2. This is the first condition. Next here second case here, the velocity at 1 by 4th of maximum height. Maximum height. V is equal to u by 2. We show that the V is equal to u by 2. So first of all, note this one. Okay. Now second case, the height is here 3 by 4th of maximum height. 3 by 4th of here maximum height. 3 by 4th of here maximum height. The velocity of the projectile at 3 by 4th of maximum height, V is equal to u by 2, half of the initial velocity. Okay, this one, yeah, this point is a Q point, P is a point of projection, Q point here 3h by here 3 by 4th of height. This is a h is equal to, okay, s is equal to 3h by 4. That means here 3 by 4th of maximum height. 3 by 4th of maximum. This is the displacement s is equal to 3h by 4. Okay. Here a is equal to minus g, and here at v is equal to, we find out v is equal to here u by 2 at point q point. Now here a is equal to minus g, s is equal to 3h by 4, 3h by 4, comma, here same, here h is equal to u square by 2g. Okay, we find out the v is equal to, we prove the u by 2. You prove the here u by 2 from third kinematic equation. V square minus u square is equal to 2as. So these values here substituting, v square minus u square is equal to 2 into minus g into, here s means 3h by 4, 3h by 4. Okay, simplifies v square minus u square is equal to, plus into minus 2g 3 by 4. H values here u square by 2g. Okay, any term get cancelled terms here g get cancelled. Okay, 2 get cancelled. So remaining v square minus u square is equal to just 3 by 4 u square. Okay, remaining terms here 3 u square by just 4. Okay, v square minus u square is equal to 3 u square by 4. Now v square is equal to, this is taken right side, so this one here, this is a negative value, so negative, this one here negative. So u square plus minus 3 u square by 4, this is taken right side, the negative value is here positive, u square remaining is equal to minus, here minus 3 u square by 4. So this is a LCM, simplifies 4 u square minus 3 u square by just 4. Okay, v square simplifies here v square is equal to 4 u square minus 3 u square, remaining just u square by 4, simplifies v is equal to under root of v is equal to u square by 4. Finally v is equal to square and 2 square, so u by 2 whole square. Okay, 2 by u by 2 whole square get cancelled. Here v is equal to u by 2. This is a prove the equation. Okay, we will prove the equation. So v is equal to u by g. That means here the velocity of the projectile body at 3 by 4th of the maximum height is equal to u by 2. This is the answer. Okay, see, చూడండి ఛానల్ని. We will meet next class. Okay, thank you, all the best.